Taking a look again at the back of the JetEng water blast machine, wanted to point out a couple of different components back here. So again, this is the primary inlet water filter. It's coarse. It's just a basic paper element. And then we have our secondary water filter. Now this is 2 micron. It's very fine in order to try and give the machine as filtered water as possible. You can get a better view here of the hydraulic accumulators that are on their new brackets. Also, this is the back view right here of the high pressure water accumulator, that stainless barrel. And that helps reduce the pulsation of the pump. Also, here's a better view of this device, which discharges all the high pressure water should you press the E-stop or turn off the intensification of the machine. This discharges all the high pressure water, making the hoses safe to disconnect or if there's some sort of problem going on. So down here, this is the water inlet, right here. This is the high pressure water outlet. And out of this comes, it's a 9/16 high pressure fitting. And this hose right here is 8mm Parker water blast hose. And I'll show a wider view of that in a moment. This is an air outlet. I'm going to talk about what that's used for in a moment. Also have accessory 1500 psi hydraulic power takeoff. So if we come back here, take a look. Here's 100 feet of high pressure Parker 8mm water blast hose. This hose has approximately 90 hours of use, so it's virtually brand new. And these hoses are very expensive. It's in perfect condition. There's no abrasion on it whatsoever, no nicks. All the fittings look brand new. Now we move on to the high pressure water valve. Now this works in tandem with the gun to turn the machine on and off. So that's what the accessory air outlet goes to. So you apply air inlet pressure here, and then not shown are 2 hoses that leave these 2 fittings that go to the hand lance or gun. So air leaves this valve and goes to pressurize the triggers. You have to pull both triggers simultaneously. It's a safety feature. When air pressure returns to this pilot actuated valve, this valve opens. So this valve can only open with air pressure, and it's fail-safe in that way. Should you disconnect a hose or something should go wrong, any loss of air closes the valve. Only opens on about 80 psi of air or more. And less than that, it springs shut. So now we'll go up. Also coming out of the valve is more Parker water blast hose, this time 6mm with a burst cover. So this is a hose that's designed for a hand lance. And you can see here all these hoses are, there you go, you can see that 40,000 psi rated. So heading back over to the side of the machine here where we have the hand lance, you can see the 2 triggers I was just talking about. Both have to be depressed simultaneously. And then we have these push-on air fittings. So the hose isn't shown right now, the 2 hoses that actuate the valve, but they're a really simple polyurethane 1/4-inch tube. It's the same thing that's used on ice makers. It's quite strong. And these are push-to-connect fittings. They're very simple. You just push this piece in and pull the hose out. And you just push the hose in tight, and it stays. They're used widely in pneumatic controls. And then, of course, in operation, all of the high pressure water comes out into the nozzle. Now this nozzle is a Stone Age Barracuda, which is a self-spinning nozzle. On a lot of machines, they are air driven. So there's an air motor in the lance or the gun that is operated and spins when you pull the trigger. I've used a few of these before, and they're really a huge pain, especially in cold temperatures. They use an enormity of air, more air than the machine can provide of itself, because it only has a 10 CFM air compressor. The valve uses virtually no air. You can turn on and off all day long, constantly. But those air-driven lances require a lot of air. You need an external compressor to operate it. And they're really a pain. There's more components to build, or there's more components to repair. So this is nice and simple. It's a self-spinning nozzle. These are quite expensive as well. It uses 4 jets or 2 with nozzle plugs. So usually you use 2 jets for really heavy coatings, thick like rubbery materials, and use 4 for more speed on like light painted, light corrosion on different substrates. So that basically takes you from all the way from the engine, through the hydraulic pump, through the intensifier, through the water filters, and through the water outlet, through the control valve, the pneumatic control valve, and ultimately all the way to where the water comes out and it does the work. So that's the overall machine. Thanks for watching.